Okay, let's finish up this section P2 on exponents and radicals. Now we're going to do some more stuff with radicals, specifically rationalizing the denominator and writing them as rational exponents instead of radicals. So to rationalize a denominator or a numerator in the form of some number a minus some number b times the square root of n, or a plus b times the square root of m, you multiply both the numerator and the denominator by a conjugate. A plus b times root m or a minus b times root m. They are conjugates of each other. You know, conjugates, every term looks the same. The only difference is the sign. Here it's a plus, here it's a minus, so those are conjugates. In the one above it, the minus is first, so its conjugate would have the plus. For cube roots, choose a rationalizing factor that generates a perfect cube. You're going to see the square root ones are pretty easy. The cube root ones or any higher power, you got to stop and do a little more thinking before you actually get started. Where's my eraser? Why? There it is. So let's try these out. We got a square root and a cube root 1 to see the difference. Here for letter A, we have 5 times 2. Square roots of 3 is the denominator. Rationalizing the denominator means to get rid of the radical. This is the square root of 3 to the first. So we're going to multiply the numerator and denominator by the same term to get rid of the radicals in the denominator. What gets rid of the square root of 3 to the first? Well, just multiplying it by itself. The square root of 3 to the first. And to be fair, of course, we have to multiply the same thing, or the numerator by the same thing, the square root of 3. And I'll drop off that first power. So we multiply straight across. 5 times our square root of 3. Now let's see what happens down here. In front of this is an implied 1, so 2 times the 1 that's there is 2. And then the square root of 3 to the first times the square root of 3 to the first is the square root of 3 squared. And that's what we wanted to have happen. You know, the square and the square root are going to cancel, and out comes the 3. And that 2 times 3 is 6. And then still up in our numerator, we have our 5 square roots of 3. So we took what they gave us, and we rationalized the denominator. It looks different, and the reason is we want to get that radical out of the denominator. We did add a radical to the numerator, but you have to do that to rationalize that denominator. Again, you know, when you start to do enough of these, when you see that square root sign, the square root of 3, you just want to multiply it by itself. Root 3 times root 3 is 3. The root of 6 times the root of 6 is 6. The root of 11 times the root of 11 is 11. Letter B. Oops. So our numerator is just a nice easy 2. Our denominator is the third root of 5 to the first power. Now to rationalize, we want to multiply the numerator and denominator by the same thing. And the key is to get this to be a third power under here. We want the third root of 5 to the third power. So we're going to multiply that by the third root of 5 to what power? Because remember, when we multiply like bases, we're going to add the exponents. If this is a 1 and we want to get to 3, we're going to have to add a 2. The third root of 5 squared. And just to be a little different in the numerator, I'm going to rewrite that as the third root of, what is 5 squared? Well, that's 25. So let's see what happens. We multiply straight across. 2 times the third root of 25. And look what happens here. We have our third root. 5 to the first times 5 squared is 5 to the third. So now that index and exponent match. Those are going to cancel each other out, take the radical with them. So now our denominator is just a 5. And our numerator is 2 times the third root of 25. And there's our rationalized expression. Now here it was just a nice simple radical in the denominator that we had to figure out what to multiply by. Here we have a denominator with 2 terms. It's a binomial. Think about this as parenthesized off 3 plus the root of 7. So we're going to multiply again by a conjugate. I'm just recopying the problem here. So we're going to multiply the numerator and denominator, again I like to look at that in parentheses, by its conjugate. And if this is 3 plus root 7, its conjugate is 3 minus root 7. And again, the same thing up top, 3 minus the root of 7. So let's multiply straight across. You might want to say here, well, I'm going to distribute that 2 across there. Don't do that right away, because some of these problems are designed to simplify near the end. So I'm just going to leave this as 2 times that quantity, 3 minus the root of 7. Now, why do we choose the conjugate like this? Well, if we FOIL it out, first term times first term, 3 times 3 is 9. Our outer terms, 3 times negative root 7, and our inner terms, 3 times positive root 7, are going to cancel out. They will, sum to 0. So then we're left with positive times negative is negative. The square root of 7 times the square root of 7 is 7. So let's leave our numerator the same, 2 times that quantity, 3 minus the root of 7. What is 9 minus 7? Well, 9 minus 7 is 2. And, if we had distributed, it'd be a little harder to simplify at this point, but now we can just cross those 2's out. Those cancel right out, so we're just left with 3 minus the square root of 7. And, here our denominator still is technically a 1. There's no radical left. We rationalized. Again, that's 3 plus root 7. The conjugate is just going to have that sign different. So when you do FOIL it out, the middle terms cancel each other out. Now, we can have radicals, and if you don't like working with radicals, sometimes it's better to change them to a rational exponent or a fractional exponent. So if a is a real number, n is a positive integer, such as that the principal nth root of a exists, then a to the power 1 over n is defined as 1 over a to the 1 over n is the nth root of a to the first, where 1 over n is the rational exponent of a. I always think about it like this. This is x, the square root of x to the first power. I am going to keep the base as whatever this radicand is, that is x, and it's going to have an exponent that is now a fraction. That fraction is formed by these numbers 1 and 2. The exponent under the radical is your numerator, the index is your denominator. So the square root of x is the same thing as x to the 1/2 power. Continuing up here in the box, moreover, if m is a positive integer and has no common factor with n, then a to the power m over n is the same as a to the 1 over n power to the mth power, or the nth root of a all to the m power. A little confusing, but let's see if I can straighten it up with this a little bit. What if we had x to the third and we were taking the 7th root? The 7th root of x to the third. Well, that's just going to be, our base stays the same as x, make a fraction, 3/7. And there we go. So in example 16, we're going to change from radical form that we were given into exponential form. So again, if you just see a number, if you see a radical with no index, that's an implied 2. If there's a number under there with no exponent, it's an implied 1. So we know it's going to be 3 raised to a fractional exponent, 1/2. Here, this again is a square root because there's no number there. And here we have a quantity in parentheses all to the 5th power. So we're going to keep that quantity, 3xy, and now we're going to give that a rational exponent. Again, under the radical is our numerator, our index is our denominator. That quantity to the 5/2 power. Let's see what happens here. We got a 2x outside, so we're going to leave that alone for now. 2x, and I'm going to give that the first power. And we now have the 4th root of x to the third. So we're going to multiply by x with a new exponent of 3/4. And let's see, we have x to the first times x to the 3/4. The bases are the same. The bases are both x, so we can add the exponents. 1 plus 3/4 is 1 3/4. And let's rewrite that as an improper fraction. 2x, and we'll change that 1 3/4 to 7/4. 2x to the 7/4 power. So here we went from radical to exponential form. Let's reverse it. Let's take from exponential form and change it into radical form. So we have a quantity here to the 3/2 power. So that quantity is what's going to exist under the radical sign, x squared plus y squared. That quantity under there is going to have an exponent. That exponent is our numerator. Here it was a 3. The denominator 2 is our index, square root of that quantity to the third power. Alrighty, letter B looks like we have a couple things going on here. This is 2, and then we have a y to the 3/4 power, and then that is times z to the 1/4 power. So we're going to do these each separately. Where our 2 has a first power, it's going to stay the same. Then we're going to have a y under a radical. Denominator is 4, so that is our index. Exponent is 3. 2 times the 4th root of y to the third. And then we have our times z to the 1/4. So that's z to the first power, and the denominator is 4, so that's our radical 4th root. And now that I look at this, I guess I don't know if the book does. You know, these examples come right out of the book. I wonder if they go as far as to say, okay, since these are both 4th roots, we can put it under 1/4 root and have y to the third z under there. Y to the third z. Again, I don't know if your book took it that far, but I guess we could take that step. And the last one now, we've got to throw a negative exponent in there. A to the negative 3/2 power. Well, to get rid of the negative exponent, let's move that to the denominator. 1 over a to the 3/2 power. And now down here it is positive. And that's going to be 1 over. We're going to have our radical with a under it. The 2 is our index, so we can put our 2 out here if we want to. A to the third power. Okay, for the huddle, the first two are rationalized. The first one is a basic radical in the denominator. Careful, that is a third root. Go back, check out the example we did. 98, you're going to have to multiply by a conjugate. And here it's different. There is no variable at all. So just multiply through there by its conjugate. In 107 to 109, here in 107 they give you radical. Write it as a rational exponent. 108, they gave you the rational exponent. Write it in radical form. And then for number 109, radical to exponential. So pause the video, try those problems, tune back in, see how you did. So for the first one, rationalize that denominator. Well, let's see, that is the third root of 2 to the first power. So I'm going to multiply top and bottom by the third root of 2 to some power, and I want my power to eventually be third power. This is 2 to the first, so I am going to need a 2 squared. And let's do it sort of like the example. This is the third root. 2 squared is just 4. So if we multiply our numerators, we get 8 times the third root of 4. And then down here we're going to have the third root of 2 to the third power. So the index and the exponent do match up. Those are going to cancel, and we're going to have a 2 left in the denominator. Our numerator is 8, third root's of 4, and this 8 divided by 2, that'll divide out to be a 4. 4 times the third root of 4. Okay, 98, that we're going to have to multiply by a conjugate. Move that up a little. So it is root 5 plus root 6. I'm going to multiply that by its conjugate, root 5 minus root 6. And to be fair, I will do the same in the denominator. And remember, that is a quantity in parentheses. You know, at some point we might want to distribute the 3 through there. Let's not right now and see what happens. So we have our 3 times quantity, root 5 minus root 6, divided by, and we FOIL this out. First term times first term, root 5 times root 5 is 5. The outers and the inners will cancel because you have a plus and a minus of the same term. And then we do our last term times our last term. Positive times negative is negative. Root 6 times root 6 is 6. So our denominator, 5 minus 6, is negative 1. And our denominator will stay the same, 3 times that root 5 minus root 6 in parentheses. And when we divide by a negative 1, we can just put a negative in front of the 3. Negative 3 times the quantity, root 5 minus root 6. Okay. And let's move on to that table, number 107 to 109. In the homework, the numbers don't match exactly, but there's some problems above these. You'll see maybe these exact same problems in your book, and you're going to do some for homework in the same section. Let's see if I can make this just a bit bigger. Okay, so here it is as a radical. This is this quantity to the first power, so I'm going to write it as negative 216, and its exponent is going to be 1/3. Reverse the process. Here we have this negative 243 to the 1/5 power. So we are going to have a negative 243 under a blank radical. The index here is the denominator 5, and this would be to the first power. So we really don't even have to write that in there. The last one, 4th root of 81 to the 3rd. We'll just rewrite that 81 and create the rational exponent. 3 is the numerator, 4 is the denominator. Okay, the assignment for this is the end of section P2, day 3. These pages and just a handful of problems. These are the ones just like the table that we just did in the huddle. Enjoy.